Good afternoon, UCelli Engineering Management Team. My name is Gerald Sorensen, and this is my equipment research for a prototype manufacturing lab. I have been tasked with creating recommendations for 3 sets of manufacturing equipment in order to outfit our prototype manufacturing lab, one for each of the 3 budget levels being considered. That would be $20,000, $75,000, and $200,000. The prototyping lab will allow for engineers at our company to design proof of concept parts and for further iterations on their prototypes. Equipment was deemed essential to have in the lab was a plastic 3D printer, a CNC milling machine, a hand soldering station, taps for tapping threaded holes in plastic and aluminum, and epoxy dispensing tools. Other optional processes that would cut down on lead time and increase efficiency that were considered were CNC cutting of 2-dimensional plastic and CNC cutting of 2-dimensional sheet metal, prototype printed circuit board fabrication, PCB pick and place machine, a PCB reflow soldering oven, spot welding, laser marking, and label printing. So research was conducted to see past attempts at outfitting a prototype manufacturing lab. Several examples of these prototyping labs were discovered in a variety of locations, ranging from universities, government agencies such as NASA, or companies that specialize in creating prototype parts for other companies. The laboratories range in size from having a large machining shop to just a handful of machines. At the minimum, all the labs contained CNC milling machines and 3D printers, while the more advanced ones had tools such as sheet metal fabrication, hydraulic fabrication, and welding soldering station. So for my proposed solution, I've decided the best course of action would be to create the budget levels so they build off of one of each other. The modularity of these budget levels in this format allows the management team to choose a lower level and upgrade to a higher one later, as each budget level contains the equipment as the budget level below it. With the different pricing levels containing the equipment for the different purposes, this will allow for the management team to choose the price level that contains all the equipment they feel is needed. But like I said before, they could choose to upgrade later and get the additional equipment. I have structured the budget level such that the $20,000 level contains machines that were deemed essential. The $75,000 one contains the essential machines, as well as the tools needed for prototype PCB work. And the $200,000 level will contain the essential machines from the $20,000 one, the PCB construction tools from the $75,000 one, as well as the other remaining metalworking and machining tools that were highlighted to increase efficiency. So for evaluating the equipment, I used a KT analysis. They were conducted for multiple models of every machine. The machines were evaluated based on their purchasing price, the floor space they took up, the precision of the machines, and the availability of serviceability and repairs. Those 4 criteria were weighted differently depending on the machine and what was more needed for its purpose. For example, a machine that required high precision had the precision weighted a lot higher than something that did not, but space was a factor, in which case space was weighted higher. So this KT table shows the process for choosing a 3D printer. The 3D printer chosen was a Replicator Plus for MakerBot. This was chosen due to its high serviceability and repair, as well as a better than its competitors in precision. The CNC milling machine chosen was the CNC Super Knee Mill. This was chosen due to its high precision and availability of serviceability as well. This one, the company supplying it, CNC Masters, offers to help with installation as well as training your employees on its use of operation. For taps, I went with the Interstate CCT 1570. This one was chosen due to its low price as well as average precision, as well as not taking up not too much space. For an epoxy dispensing station, I went with the Touchdown adhesive dispenser. This is a desktop mounted unit with a built-in electric pump and heater, which allows for very easy application of the epoxy to a surface. And then for soldering station, I went with the Hako soldering station. This was under $1,000, and it works well with soldering and unsoldering. It was chosen for its ease of serviceability as well as precision for a decent price. Like I said before, the essential equipment level consists of the MakerBot Replicator Plus, the CNC Super Knee Mill, the Hako rework station, the Interstate CCT 1570 tap and die set, and the Touchstone adhesive dispenser with heater. The sum of these equipment is equal to about $19,562. The equipment on this level allows for a diverse basis of prototyping, and this allows the engineers to conduct additive and subtractive manufacturing, basic soldering, rework, as well as creating threads on part and applying an epoxy adhesive. However, this budget lacks a specific focus on an area of manufacturing, providing enough abilities for the engineers to be able to innovate designs, but requires many processes to be outsourced. Moving forward, this is the KT analysis for the pick and place machine. The LNP64S automatic pick and place machine was chosen. And then for the prototype printed circuit board fabrication, the Prinsta 1001 was chosen. This one was chosen due to its high precision as well as ease of serviceability. For a reflow soldering oven, the M8 reflow oven was chosen. This one had very little lead time as well as containing multiple heating zones, allowing more customization on how much heat you want to apply to the boards while reheating, reflowing. So this is the budget level for the $75,000 one. As previously mentioned, it contains the essential equipment with addition to the machines dedicated to the prototype circuit board production. The cost of this budget is higher at about $74,204. This budget level retains the previous essential equipment at the first level, while allowing for almost full production of prototype circuit boards to be constructed in-house, decreasing lead time and allowing engineers to create innovative designs faster. The main advantages of this budget level are the retention of essential prototyping machines, along with the ability to create the prototype circuit board. However, this budget level does cost about 4 times the base level and lacks any more dedicated metalworking or machining tools that the upper budget has. So for the CNC of 2-dimensional plastic, we chose the Grizzly GO874. For the CNC cutting of 2-dimensional metal, we chose the Torchmate 4400 CNC plasma cutter. For spot welding, I went with the PPBI Profab automatic spot welder. For laser marking, I went with the Boss FMS laser marking machine. Label printing, we went with the Epson Colorworks C7500G. And I added a CNC lathe while it was not part of the optional equipment that was recommended. I felt that it had a very valid place in a machining shop for creating prototypes, and so I added it myself. For this one, we went with the ST10 CNC lathe. So this is the final lineup for the $200,000 budget level. This budget level comes in about $198,527. This budget level retains the previous essential equipment of the first level in the full production of the circuit boards from the second level, with the inclusion of a lot of machining equipment requiring next to no processes to be outsourced. Like I said, we're not part of the original set of optional processes. I recommend the addition of a CNC lathe, as this is normally a vital machine found in machine shops and will increase the efficiency and a range of producible parts in the lab. The main advantages of this budget level are the retention of previous budget levels equipment, along with a large variety of machining tools added. This will give the engineers of the company almost all the tools they need to innovate new products, whether small incremental changes or disruptive or radical changes to the industry. The main disadvantage of this level is its large price tag, coming in about 10 times the price of the essential budget level of the first one. So all the machines were chosen not only for their price and size, but also their precision and serviceability. Many of the high-end machines chosen have fantastic customer service, often forming good long-term relationships with their customers, including help installing the machines and training employees on the machines. Their high precision allows for the engineers to be able to innovate new designs and require very fine tolerances. This solution should fit perfectly for the problem that utility engineer is facing with deciding what budget levels to invest in to supply the new manufacturing lab with machines. The incremental increase of equipment with each budget level should clearly indicate what capabilities are gained or lacking at each price point. The modularity of the budget levels allows for the management team to choose a lower level and upgrade to a higher one later, as each budget level contains equipment of the ones below it. This will allow more processes to be brought in-house to create prototypes faster, cheaper, and not requiring much outsourcing. As a side note, as no size constraints of the prototyping lab was given, it was assumed to be large enough to fit all the equipment. If the size of the space is determined to be a large factor later, I recommend the THC tables are revisited with a larger weighting given to the size footprint of the machines in order to choose machines that better fit this place. Thank you for your time.